use this for your lab. So that's actually very then. So last week we were, I believe we were here. Is that right? We were right here. So let's go ahead and see where we left off. By the way, another question I had over the weekend was, how do I use ggplot? Well, please refer to your slides. This is like this first in this deck of slides here, plotting and basic data transformations. I have this cheat sheet that you can look at, which talks about how the plotting function actually works. I hope that that's helpful. If it isn't, then please let me know. But I'm hoping that it's actually quite helpful. It talks about the ggplot function itself, where you have to assign the data. This function over here creates what they call the canvas. And then it has this piece of the function called mapping, which is to basically order the brushes and the paint and the sizes and the stripes and everything you're putting into your canvas. And this is all orchestrated by this function here called AES, which is the aesthetic function, which then determines where the points are and then how to decorate them. And so this is your cheat sheet. But all these ggplot functions work almost exactly the same. Some people make some shorthanded things here where these are assigned to variables. But the structure, though, ultimately, when everything is said and done, it's the same thing. So I hope that helps. Okay, so let's get back to where we were. We were talking about transforming types of data. Let me see here. I'm trying to find exactly where we were. I think we're on the 31st. We're talking about different types here, and I think this is where we ended up. This is called the dplyr basics. So today we're talking about how you can pick observations from data tables, how you can reorder the rows, how you can pick our specific entries by like their names, for instance, how you like the column names, how you can create new variables, in other words, how you can add more data to a column that you have. You can calculate something and then add another column onto the side. And we're going to talk about how you can kind of bring things down to a more kind of, you can organize your data into a more, I would say, digestible way of reading it. These functions, I'm hoping that if you know about LibreOffice Calc or spreadsheets, working with spreadsheets here, I'm hoping that you'll recognize some of these functionalities when working with spreadsheets. I mean, some of them are actually exactly the same thing, but in this case, we just have we don't have a menu option that we can click on. We actually have a command that we have to type in, but the result is exactly the same. So let's go ahead and get back to our studio here. Let's get back to our studio. Our studio is right here where if I switch over to my transition, let me just go ahead and find this on my screen. You don't see this, but I have like on my desktop, I have like windows everywhere. It's like it's hard to find anything. And so it looks like I'm getting lost in my own machine, but actually it's just because I'm clicking around. Okay, so what we're going to do now is I'll close this, close that. Actually, I don't need this just yet. I'll leave that there. But our notes from our September 24th, we first of all, well, maybe I'll start all over again down here. We'll hit that. I'll just work down here. So getting back to our slides here, we're working with this data set here called flights. Now flights, as you remember, we can pick up that data set from, there's a slide before. Let me just go back and show you that slide. But it was flights NYC, I believe. And where is that? It's right here. So if you have not yet installed this package, you're going to need this package here. I'll just show you how to do this. But this is the package that installs this information about flights. Flights meaning, the airplanes that take off and land in the continental United States for, I think, every day of the year. Or is it I think it's every day of the year from all the major airports. So I'm going to go ahead and copy this. You can't really see me copying anything. But when I go back to my RStudio, you'll see that I'll just dump everything into this. I'm making a source file here. I'm just putting it in right there. Now this is going to install the library, and I do this if I have never installed this library before. So in other words, if you're using a machine or you have something, if you're using Docker, for instance, you may need to, if you're using a container, you may need to install your libraries. It depends on how you set up your containers, but typically, unless you have any fancy code, you'll have to reinstall your packages whenever you use Docker. Now, once you have installed this thing, I'm going to assume that everyone installs this thing without any trouble. I don't think there'll be any trouble with this particular installation. But once you've installed it, what I like to do is I put that tag there. And what I do, and why I do that is because that helps me I can leave this code in my code, but I don't want to, I can leave this line of code in my code, but I don't want to run this every time I run this particular set. And the reason for that is because when you have really extensive R code, you may be using, I don't know, 10 different libraries. And each 10 library is going to cost maybe, I don't know, from 15 seconds to 30 seconds to install. And so every time you rerun this thing, if you're reinstalling your packages, which is unnecessary, then it might take you a minute or 2 minutes to actually run the software. And that's totally unnecessary. All you need to do is once you have this installed, is you can use this, you can go back to our slides here, and you'll find out the next command is called library NYC flights 13. The 13, by the way, stands for the year 2013. So if you run that, if you just put that in your code here, and then you go to the, you can't really see what I'm clicking on, or can you? Maybe you can't. No, you can't. But if you click on the run, then nothing is going to happen. I mean, you just put your cursor right here, leave it right there, or you can leave it anywhere you want. It doesn't have to be at the end, but leave it anywhere on that line, and you push run, and then you'll just see that this library NYC flights has shown up, but there's no result here. So that's a good thing. Typically, when libraries are installed, it means that you're not going to get any result back to say that the library is actually being kind of brought into the code. You can see that it actually worked by typing V, capital V, I-E-W, view, and the data set is called flights. And, excuse me, and when you click on flights, then you're going to see this table pop up. Now, this is your table that has all the flight information. So let's just see this again. We have year, month, day, the departure time. I don't know if you can see my departure, but the departure time, and you can see the scheduled departure time. So there is a difference. One is the time when the plane was supposed to leave, and the other one is when the plane actually did leave. So that's your departure time. And then we have this departure delay here, which is the difference between the scheduled time and the actual time that it left. So that's in this case 2. Now, if I were putting this data set together, I would skip this column here. I mean, you can see this. I would skip the departure delay column because it's redundant. I can calculate this column on the fly if I need it. And that's just by subtracting the scheduled departure time from the departure time. And that would give me this number 2. So there's that. Then we have the arrival time, which is when the plane landed. And then we have the scheduled arrival time, which is like when it was supposed to land. And then again, we have the difference between those two, which is the arrival delay. We have carrier, flight, tail number, origin, destination, airtime, like how much time was it actually in the air. Again, airtime is another redundant variable, I would argue, because you could probably just subtract the arrival time from the departure time, or rather the departure time from the arrival time, and figure out how much time has elapsed while the plane was in the air. So it's funny, actually, this data set, you have all this information in here, but most of it you'll probably never use, and some of it might just be redundant. So then we have the origin and destination. That's interesting. We have the airtime. We have the distance, how many miles this plane has flown. I guess the hours that the flight was going, the minutes that the flight was going, and the time, I guess the time in hours here. So let's see. I'm not sure whether the time in hours when it took off or when it landed. We'll have to look into that and see. But actually, we can look into these things. If you type in $flights, then you have this. I don't know if you can see where I am down here. But you have this help that you can type in. If you just type in this line here with a question mark with the flights in front of it, you have this online help, and the online help is what they call a code book. No, this isn't like some kind of cereal box toy here, but a code book is actually information that discusses where this data came from, maybe who collected it, why it was collected, and some of the situations which were involved when it was collected. These things are actually very important. Especially in medical data, because if you're collecting data on, say, people who are sick with, I don't know, the coronavirus, you might need some information about maybe where the information was taken, under what conditions, How late into the pandemic was there, or was it when the information was taken? You need to know this kind of information to actually perform an assessment here, because that will help to inform your results. So you can see that going down to the bottom here, time hour. In this thing, it says it's the scheduled date and hour of the flight as the POSIX date, along with the origin, and can be used to join flight data to weather data. So you'd use this to connect this to other types of data. We're not going to worry about the weather data here. That would be information about how turbulent was the air, whether the flight was shaken around, whether it was late because of wind, all those kinds of things. Yeah, you can also see, for instance, the source is also very important. You can see whether the source is actually credible. You may find that going online you find data sets, but the data sets are not credible because it's just one person who is maybe coming up with this data on their own, and maybe their instrumentation is faulty, and so maybe it doesn't actually give you any good readings. And so you need to know where it's come from. And this comes from the Bureau of Transportation. Sounds quite intelligent. Okay, so let's go back to our slides and see where we are from this. And so we've done all this stuff here. There's one thing I wanted to show you was this at the bottom here called names. While we have just been able to see the names by looking at the tops of these columns, there's this other command that we can type in here called names, flights, whoops, and it will tell you the actual column headers themselves. So now you don't have to go to the table and view them, but actually you can see them as a list. And this actually makes it helpful because you might be doing some kind of analysis here where you have to look something up in the table automatically, and you need to go to a specific column and then find something in some row. Anyway, now you have the column headers though, so you can use those as you need them. Right. I'll put that in here just in case I want it again. Let's get back to the slides here. So going back over this way, let's see. Okay, we just covered that. And so now I'm going to go back to our where is it here? These dplyr basics here. So now we're going to talk about how do you pick observations by values. Well, what does that even mean? We're talking about the filter command. And so the filter command is saying, okay, well, give me the rows here, which have specific types of requirements here. So let me just go ahead and copy this in, and I'll just show you what it does. And then once it's in, you'll see. Actually, it's here. Okay, I'll put this right here. So filter flights. So the filter command is this. The next piece that we have to put in, the next piece of information in this function. This is a built-in function now. But the next piece of information is, in fact, I wonder whether I should have to put in tidyverse. Don't forget to put in tidyverse here. You'll need to run that. Make sure the tidyverse is running, otherwise it's not going to work. So filter is a tidyverse thing, a tidyverse built-in function. So the first thing is your flights, and then over here I'm saying that I want to know about the month equals 1 and the day equals 1. So what just happened? Well, let's go back to our flights data for a second here. Now, where is that? Here we are. Notice that we have the year, the month, and the day. So the month is, in this case, 1, but that means that we can still go down. In fact, I'll go down to almost to the bottom here. And you can see here's the month equals 7, and the day is equal to 2. And so almost for the entire year, we have seemingly all the data that exists. In fact, I think the data eventually ends on the 9th month. At least that's what my data is saying here, on the 9th month. And so we have seemingly all 1 through 9 months you can pick from. Now, this function that I just talked about here, this function filter, says, okay, give me all the rows, and I'll take everything, for which the month is equal to 1 and the day is equal to 1. So in other words, give me the data that happened on January 1st. That's what this is all about, January 1st. And so you're now able to pick out not all the rows, but you can actually focus in on a specific area of your data. And when I'm saying your area, in this case, I'm talking about you can actually focus on the 1st of January and collect that information. So in other words, you can collect all this information here. You can see this. You can collect all this information here, and then ignore anything that says month is equal to or day is equal to 2, like this. You can ignore this because this is no longer relevant. Say the month is correct, but the day is not correct, and so we can ignore that. And so that's really what this function here does. And I think that the more you use it, the more handy you'll find it. Yes, sir. So the question is, why did we not get everything? Why was only 10 observations shown up? We did only get 10 observations here. Everything else is actually in memory, but to save space, our studio doesn't show everything, which is really kind of annoying though. So that's the thing. So that's why it only just shows us the 10 things off the top. So the next thing we need to do then is, if we wanted to actually get to everything, I want to see everything. I want to see everything in this kind of in this spreadsheet format on the top of my screen here. What I would do is I would say my data. You'd assign it to this thing. There's other ways of doing this. And notice now, for instance, in your global variables, I hope you can see this in the upper right, I've now created this variable. If you click on that, you will see, all I did is I typed in this code here. In fact, what I should do is I should put this code into my special code that I'm working with here. There we go, save that, and I'll go back here. So my data, this shows us all the data that we can work with. And so getting back to your question, so this is how you do this. You'd have to, in order to actually to look through the data in this nice, neat table here, I think that it would be best to assign this as a variable and then to go through the variable in this table up here. This is, by the way, what they call a data frame. A data frame is a kind of a small spreadsheet. You know, hopefully that answers your question. Yeah. So please let me know if you have any other questions. I mean, let me know here. Go ahead and just unmute and ask. There's no such thing as a bad question. They're all wonderful. Now I'm going to go back to my slides and see what's next on the thing here. So this over here, this is another example that I picked up here, is we don't have to just limit ourselves to like the month and the day. In fact, if anything, we can go after specific like other columns too. And so in this example here, I'm going after, give me all the information, all the rows of information here, for which the month is equal to 0, and the departure time is equal to 554. So maybe that's my analysis. Maybe that's where I'm going after. Maybe I have a feeling that flights at that departure time had some kind of, there's something different going on with them that could be explained in the data, and so I need to investigate. How can I do this? Oops, how do I get out of this? Go away. There we are. So I'll go back here and just put this next piece in here. So I'll just run this departure time, and again, this goes back to the question that I just had. I'm only seeing 10 rows here, but that doesn't mean that that's the only available data. It means that actually there's more information coming through, but I just don't see it on my screen. These little dots down here is where that's how you'd know that there's more information than just 10. But what I want to show, what I want to say though is, look at how departure time now, all these points here are all equal to 554. Now let's go back to, I'm going to close these just so I don't confuse myself. There we are. I'll go up to my flights information. Now I have departure time here, which is I have year, month, day, and departure time. You'll notice that these are all different types of numbers here. They go from 517, I see, and in fact I can click this. If I go into the button itself, the header itself, and I click this thing, there's like a little up and down arrow in that header. I don't know if you can see from where you are. But if I click on that up and down arrow, then that means I can sort this column, and it means that the departure time, the biggest number that's there is 2400. And so now I can go after seemingly any one of these numbers. And so this code that I just typed in says go after only those rows for which the departure time is equal to 554. I could change that. Let's see, what was my numbers here? Let's go and see what's happening around, like, I guess it's like 9 o'clock here. So 9 o'clock would be 2100 hours. And so I could change this. Let's go ahead and change that here. Let's go ahead and try this. I mean, choose any number. It doesn't have to be this one, but any number would be fine. And now you'll see that my departure time is the information for which the departure time is equal to 2100. And everything else is the same, by the way. Nothing else. It's the how this works is that all these rows are exactly They're all tuples. And so everything kind of belongs together. And so you have a scanner that's going through in the R programming language. You have a scanner that's going through and it's looking at each one of these values in the scheduled departure time. And when the time is equal to, say in this case, 2100, then it grabs the entire row, everything, the whole thing. Nothing is left out. If, for instance, it goes to the next row and it finds this is 2359, that doesn't meet the requirements, and so therefore it skips and it moves on and on and on until it exhausts all the rows in this data set. Now, I will say that some of these commands, though, when you have a huge, absolutely enormous data set, they can take some time because you're essentially going through and running a test on every single row. But I don't think that that's actually, it's not like, it doesn't take like, hours. You might have time, though, to get up and get a drink, okay, and then come back and then watch the results come through. And so sometimes it does take some time. If you're using an older machine, you might notice it more than a newer machine. Okay, very cool, very, very cool. This goes back to the question here, if you want to save these results as a variable, and this is what I find that when I first looked at RStudio, or even the R programming language, I found this actually kind of difficult to swallow, and that I was used to looking at variables as like one variable, one number, one string, one something, okay? It's just one. But in this case, it's not that way. So when I run this variable is being assigned to the results of this query here, which is really a small spreadsheet. And so now my whole spreadsheet is being called by departure flights 554. And that makes me think of something else I should mention. Please notice the name of the variable that we're using here, 554. You're probably thinking, what is that, someone's phone number? No, it's not. You might want to use something that's descriptive. You'll notice that my departure time is 554. For those of you at home, you can hear this line noise. That's actually the lawnmower outside the window. Cool. But I'm using this departure time 554 number here, and I'm actually embedding this into my variable name because I may have several different variables that I'm going to be comparing here. And so it's helpful having something like 554 to recognize that this is 554 here, the departure time is 554. So as you're making your variables, please, you could just say x is equal to this. I could say, for instance, x is equal to this thing here, and that would give me my variable up here, x. But x is not very descriptive. It doesn't give you any information at all. And so what I would recommend is just going ahead and putting a variable name which actually does make sense to you, because it'll be late. You're working through your results, and then you'll think to yourself, wait a minute, I have this variable that's giving all these crazy answers. What was that variable? How did I come up with that variable? And if you have something that's informative, then it will help you to do your analysis. You can do some other things too. You can have you can use comparisons. You can use like basic less than equals, greater than, not equal to, equals and not equals. You can use those types of operators on your data set. So this is, again, going back to month. I'm going to go back and see how I can just grab all my data for this month, where the month is equal to 0. Oh, sorry, is equal to 1. Sorry. If I do this, I get this information where month is equal to 1. In fact, if I want, let's just say, how about 6? I can see that all the data for my month is equal to 6. But I can kind of like actually specifically point out which month I want. Here's 6. How about 4? Let's see what happens in April. So we can go after April months. But now I can also do something else which is actually kind of cool, where I can go and say, okay, well, where month is at least April all the way to the end of the year. So I'd have greater than or equal to 4. And you'll see now that it just says 10. Let me just show you what I can do. I'll just say that April onward, that's what I'll call my data set. April onward is going to be equal to the filtration of flights for which the month is at least equal to 4. And so if I look at my April onward, which is up here, you'll see that I have the month is 10 in this case. In fact, if I click on the, I wish you could see what I see here, but I'm clicking on the button itself for month, and you can resort things just above where I am right now. If you can see that. But I can click on the month column, and it sorts the data for me. Again, if your data set is really big, it might take some time to sort, but it will happen. But you can see now that the biggest month I have is 12, and the smallest month I have is 4, and that's because this data set that I have, April onward, was actually defined where the month is at least equal to 4. So you can change this around here. Let's say that I'll just modify this. I'll leave this here. But I can say, for instance, where the month is equal to, let's say 10. So what's the 10th month here? January, February, March, April, May, June, July, August, September, October. So October onwards. So I'll call this October onwards. Oct onwards. And so if I run this, if you can see this, there we go. I've just created, in fact, let me just move this down so there's a little bit more space to see what I've just been doing. It's right here. So I click on Oct onward, and you can see now that the biggest month is 10, sorry, the biggest month is 12, rather, and the smallest month is 10. And so you can actually kind of target specific months of data. This is a very important skill to have in your hands, because when you're doing analyses, especially like in tourist season things, or you're looking to see how many people are on flights, or even like, for instance, anything where you have some kind of a where the time is important. The timing is important, like when something happened. You know, if you're looking at when people use hotels, was the summer the biggest season for hotels, or was it the winter? And like the question of when, you can use something like filter now to actually go after specific months in which you're believing that you like to do your research. Now, another thing I'd like to do is between January. I'm making another variable here. Between January and March, you'll notice that when I write my variables here, they become quite long, and that's okay, because it's better to spend the time typing in variable names than to be pulling out your hair trying to remember what this variable means, like where did it come from. So what I'm going to say here is I'm going to do this. I'm going to say, okay, between January and March, and so that means where the month is going to be greater than or equal to month 1. And then we have this, I think we put and here. In fact, if I go back to my slides here, I can actually see what it is. You can actually put an and here, and I think your and is going to be, in this case, you'd have like an and sign, an ampersand. And so that's how you'd use it. So I'll put an and. Month is less than, what's March 3. Hope that works. Okay, so I've just run this code here between January and March, and it seemed like it worked okay. And so where do I have here? Is this one here? So I click on in my data, in my global variables. I can see that my month now is actually equal to 1 for the lowest month, and the top month is going to be equal to 2 here. One thing I would like to say, though, is that the way that I put my math together, notice this is a big problem that I always have. Notice that this month is less than or equal to 3. That means that it's never actually equal to 3. It's less than 3. It's never actually equal to 3. So that means that when you're doing your analysis, or even if you're saying this happened in March, you have to think to yourself whether it's inclusive or not inclusive. So in this case, I'm saying I'm including the month of January, because that's where this equal sign comes from. But the month of March is not included in my results. In other words, this is just capturing January and February. Now, if I wanted to have March, I think I could do something like this. Is that right? And that would pull in this over here. So let's see, month is 1, and month is, so I have the smallest month is 1, and the largest month is 3. So what I'd recommend is that as you are going through your analysis question here, determine for yourself whether you want to have these months included. Like, are you including January and March, or do you just want the stuff in the middle? Do you want those end months too, or do you want like the whole block, January, February, and March? And so you have to decide that. So anyway, I'm just throwing this stuff out in case you need it. Let's go back to the slides here again, and I think we should kind of like discuss that. This is another example you can do here. in the slides where, for instance, now we're looking at give me all the flights here such that the arrival and the departure delay was within 120. This is in minutes. So in other words, give me all the flights for which the delay was at most 2 hours. That's what this question is. Another thing that's actually kind of something you have to take time to think about is that when you're actually formulating your question, you have to be able to think in terms of like the mathematics of how you would answer that question. So this is saying, give me all the flights. Whoops. Give me all the flights for which the delay was less than 2 hours and the departure delay was less than 2 hours. So these delays were less than 2 hours. That means you may have flights which were delayed by 3 hours. That can happen. But these are flights that were not delayed by more than 2 hours, or actually 2 hours or less. And you can see that by this less than or equals, less than or equals. And the data looks like this. And so you can see, in fact, I might do what we did before, where I'm going to actually assign a variable to this, just so that I can see what's going on. I'll just say 2 hour delay. Give it a variable, watch the global variables, and boom, just shows up here, 2 hour delay. I can click on that, and then I can actually kind of take some time to look into my data. So I'm looking at the scheduled departure time and the scheduled arrival time. These numbers here, 1:15 or 5:15 and 8:19, these are the kinds of hours that were, that's where the tests came from here. Anyway, so this type of question here would go after this type of analysis would go after were the flights that were, relatively speaking, on time within 2 hours. Were those flights perhaps in areas, you could ask, were they in areas which were more sunny, or maybe there's less likely to have snowstorms, or maybe there's, I mean, could you somehow liken it? Could you find some correlation to the flights that took off, certainly, quote unquote, on time, or within 2 hours? Could that be because maybe the weather is more favorable? Maybe these are flights that are coming from places where you don't have huge, heavy snowdrifts that prevent things from happening. Or maybe, for instance, the delays between flights, or the flights that had delays of less than 2 hours, were less likely to happen. Those delays were less likely to happen in summer than they were in winter, for instance. So you can ask those kinds of questions, though. I'm not going to run these questions, but if you're interested, then I do encourage you to go back and do that. But we don't have all the tools just yet, though, to run that analysis. That's actually asking about that's what we're looking for, a correlation. But we can come back to these ideas. Okey-doke. So let's move here and talk about the next one. So the next one is called a range. Now, a range is very similar to the sort command in a spreadsheet. In fact, I don't know why they just don't call it sort. I think that the term sort was taken by something else, and so they just use now a range, which is simply the same thing. But what a range actually does is it takes your column. In fact, we've been doing this. If I go back to this, for instance, I've been clicking on these. If I go back to my flights information, you see how, for instance, I have if I click on the header names, the actual headers on the spreadsheet above. Like, for instance, here I am at departure time. I can click on this departure time, and then I can move the numbers back and forth. I'm just sorting the data, but that's me clicking on a button. So this command here, arrange, actually allows me to write that into my code, because I might want to make some kind of analysis here where I'm grabbing the top 3 times or something. Or maybe I'm saying that give me the top 3 departure times, or the top 3 fastest planes, or whatever it may be. So arrange. I'm going to go ahead and put this. I'll copy that, and I'll go back to my slides here. Okay, sorry, go back to RStudio, and I'll go back to where I've been working. In fact, I'm going to remove this, get rid of some of these things on top here so they don't keep confusing me. Get rid of all that stuff here. In fact, I'm going to get rid of my some of these variables, and you can get rid of your variables by typing rm list is equal to ls. I know that looks like a really crazy looking function here, but actually it removes my global variables. And so you might want to have this kind of clean space. I'm going to go ahead and put this down here. And what I always do is, once I have removed my variables, like as I have right here, I reinstall my libraries just in case. In fact, I have this all here that I can just copy just because I'm lazy. And so it removes your variables, and I think that sometimes if you reinstall your libraries, it might make a difference. So I have this over here, remove anything, and I remove all my variables. I'm reinstalling my libraries and reinstalling other libraries. So then I know now that I have really what they call a clean slate when it comes to working with this. Now, going back to, oops, just lost it, there we are. Going back to my arrange command here, oops. Remember I have arrange. My command is this. Now I have to tell it what data set I'm using. Flights. This flights data is built into this. And so when I run this library, NYC flights 13, now I have access to this data set here. If I don't run this library, if I have a brand new piece of code where I dump everything and I have no libraries loaded, and I try and run flights, it will give me some kind of an error message because it says it will say I don't know what flights is. But flights is coming from this, and so when I load this library, I get this data set that comes in. And that's, I think, really what it does. I don't think there's any other purpose to that library. I think it's just this data set. Okay, so I'm going to go after the minute now. Oops, I guess it helps to spell correctly. I'm not the best speller. In fact, many of you have already pointed that out in my labs, that I'm really not a very good speller. It doesn't hurt my feelings. I'm glad that you do. But I was always the very last speller ever when I was in elementary school. So, yeah, I'm bad at spelling. And so if anyone finds spelling mistakes in my things, please point them out, because otherwise I probably wouldn't see them, because I just don't. So thank you. I'm going to go ahead and run this thing here. So arrange. Now, what this has done is, you don't really see this, and this goes back again to the question that we had previously. I'm only seeing the top 10 results. I mean, this is actually kind of annoying. I mean, now that you've asked your question, it's kind of actually, it's beginning to bother me. Like, why is it I can't see the rest of my data? It just doesn't, R just doesn't want to fill up my screen with all these things here. So what I recommend is actually assigning a variable here. So I'll call this minutes arranged, or something, ARANGE. Something like that. Just, oops. So I have this, I'll just give it some variable. It's just some throwaway variable. Don't worry about that. You can give it any name you want. And if I click on my data for my global variables, then you'll see that now I have created, where's my minutes here? Minutes are all the way at the other end of the spectrum here, the other on the far right. Okay, so you'll notice that as I move down this data set, it starts with 0, and I'm just going to scroll down through the middle here. Now you'll see that my minutes are at 45. If I keep on moving down, so 45. Oh my goodness gracious. I'll move down further. Now you can see that the minutes actually are ascending here. They're getting to be bigger numbers as we get to the bottom of the list here. So that's how you'd use the arrange piece of code here. Now you would use this. You're probably thinking, why would I care about arranging my data in such a way? What does that mean for my results? Well, because if you are, for instance, working with chronological data, and you have a big table like the flight data, you may need that timing data to be in order so that you can use ggplot to kind of go through and plot things according to time. And so that's why you would use it. You'd create a new data set, a copy of the old data set, where everything is in some kind of an order. The next thing I'm going to talk about is this other, what if I have like another parameter down here? I have 2 parameters. So now what I'm going to be doing, oops, I'm going to be arranging flights and minutes. And then what happens if can I filter this? Actually, is this the same old thing? This is the same old thing? No. Let's see what happens here. Let's just run this and see what happens here. I think that we have to actually create a, let's go back here. I think we have to, let's dump this in here and see what I can do. Excuse me. So, oh, I know what this is talking about all right. Well, anyway, so if I arrange this here, then we can get the minutes here as we have already seen. But now I'm going to have to change. What you're supposed to see here is that you get when you run this filter here, you're just pulling out the flights for which the day is equal to 30 and the departure time is equal to 554, but they're not really connected, these things. And so what you can do is you can always say that, for instance, I'll just say that, I'll just give it the same name here again, just because. I'll say minutes of range is equal to this, and then what I'm going to do is I have to take this data set and I have to dump it in here, so that now I'm filtering this. And so this is how you can kind of tie things together. So first of all, I'm making a new data set for which the flights data set that I've been working with is actually organized by minute. In fact, we've done that up here. And now what I'm doing is I'm filtering out through this thing here all the information for which the day is equal to 30 and the time, or the departure time, is equal to 554. And so now if I run this, in fact, I need to, let me just make another variable here so you can see this. Filter, and I'll put day 30 and dep time 554. This is just my crazy name for a variable. It's extremely long. I tend to do this to give you an idea about where that variable came from. It doesn't matter. You can, I think that when you type in R here, for instance, there you are. When you're typing, oh, you can see it, okay. When you're typing in R, if I begin typing the name of my variable, then eventually I get this list, and so that's how I keep going back to these variable names. And so that means that I can make these names as long as I like. And I would say that make them as long as we possibly can to help you figure out how to use them. In fact, this is, which one is it I'm looking at now? This is fun. So this is my data set that I'm looking at. Filter day 30, departure time 554. You can see that now my minute, if I go over here, where is it? Here we are. So the minutes, if you see on the far right, are in order, but now I've selected all the rows for which the departure time is equal to 554, and the day is equal to 30. And so I'm able to tie together my two functions. And so going back to the actual slides here, what happens here? Well, you get two separate events that happen. What you want to do is you want to put a variable on this, call this something, give it a name for this, and then to put that variable name down here, so that you're combining the arrange and the filter commands together. That was a trick question. That's why it's red. So anyway, that's how you can bring things together, and hopefully, well, you'll see that again. You'll see it again. We have this other thing here called, we can make things go in descending order by this arrange. We can basically, when you sort things, it goes in ascending order, but now we can make it go in descending order. And that command is this. We have descending, and this over here is your arrival delay. I'll just go ahead and put it into the code, and so you can just see what it looks like when it runs. But otherwise, it's not really, it's not as exciting as it sounds. If I run this, arrival delay, can I even see that here? I can't see it, so I'm going to make a variable. I'll just call it arrival delay descending. It doesn't matter at this point what the variable name is, just as long as I have something here, which is right here. So I look at this thing, you'll see that my arrival delay is here, this number here, that number. So you can see that 1242, or sorry, 1274, 1127, 1109, these numbers are actually decreasing as the list goes on. That's what they mean by the descending quality of the, oops, that's why they mean it's descending. Now that might be important because maybe you're doing some kind of an analysis of time and you want your time not to go forward, but you want it to go back, to count backwards from some point. And so you can now grab pieces of information here going backwards from some time. I'm going to go back to the slides just to see. I think we should move it more quickly here because otherwise we're running out of time. The next thing we have is a command called select. Select is actually quite important because now we are pulling in specific columns. Before we've been grabbing rows. Notice we've been always going after rows. But you might think, well, I don't want all these columns. In other words, going back to this data set here, I don't need to know about, for instance, the carrier, the flight, the tail number, the origin, the destination. I don't need that information. That's just using up space in my computer. And so I'm going to actually create a smaller data set where I'm going to ignore that. And so to do that, you'd use this function select. And so what this is going to do is, I'll just use this command right here. It's sometimes difficult for me to actually copy everything here. Hopefully that'll do that. But if I go back to my studio, I'm going to run my, in fact, I'll put this in my code. Yes, I've got it. But select those flights. In fact, I'll just give it a name here. Select flight. Yes. Okay, I'm giving it a name here. And so now you'll see that my select flights variable has just popped up over here. I click on this, and you'll see now that my data set has been transformed from flights with all that extra stuff down to only 3 columns, for which the year, the month, and the day are present. So where did that come from? Well, here I have my select function right here. Again, flights is the data set that I'm working on. You always have to tell these functions which data set you're working with. In this case, I have to say that I'm working with flights, and that's my data set. But then I have to say what columns I want, year, month, and day. And remember, I can type in this command here, names, and now I can see what's on the menu, what can I select. And so this flights names here, I can say, okay, well, these are the columns that I have to choose from. I can just add those names in here, and I can grab all this information here. So let's go ahead and try something here. I'm going to go back and amend this function. I want not to select the flights. Nobody told me I missed out an I. Really? Really, you guys, really? Selecting flights, I want the, let's just say I want the destination and the hour. Oops, I'll put this up here. Destination and hour. And so what I would do is I'd remove all this information here. And again, I have to say where I'm selecting my information from. That's my data set. And I'm going to say, okay, destination. And I know that that's actually it's lowercase dest, so I do lowercase d. And then I have to have hour. Again, it's all lowercase. Oops. So now, make it look pretty. If I run this, I get another one of these things that shows up. But now I have in my data frame, I'll start calling them frames because that's what it is. It's a frame. A frame is an ordered list or an ordered table of data you can work with. You can see that I have destination and hour. So now you can actually pick out specific columns, which I think you'll find in the next, maybe not this lab that we're working with now necessarily, but in our next lab, you'll find this to be very, very handy because you're going to have a data set where you'll have to pull out columns to work with. You don't want everything. You just want specific things. And one of the questions is actually pull out those specific things. And so you'll be using this, almost exactly this same function right here. So take note. It's all very exciting. I'm going to try something else. I'm going to say what happens if, I'm not going to assign a variable to this just because that might be a little bit silly. But if I just go ahead and I'll spell destination with an uppercase D, does that make any difference? And you'll see that, for instance, big D dest doesn't exist. And that's because the destination has a lowercase d. And I'll say that probably for me, whenever I have trouble using this function with my variables, it's exactly this problem here, that I've uppercased something which should be lowercase. So please take note of that too. That'll save you so much time. I'm going to go ahead and put this code down at the bottom here. I'm going to clear everything out so I can have my global environment is cleaned out. And there we are, it's all clean now. And we can move on to the next thing here. Let's go back to the slides. Let's see. Oh, yeah. One thing I should talk about here is, this is actually quite important here, this piece, flights. You can actually grab information between different, you can grab columns inclusively. That means you can say, okay, well, give me all these columns between the year and the day. So let's just see what that looks like. Going back here, going over there. Let's see. Maybe I'll put this above here before. Just put that there. So again, I'm going to be selecting the flights. I want the year and the day. If I run this, you'll see that, where did it come up here? Let me get a variable here. I'll just call it year, day, flights. Okay, year, day, flights. If I click on this, I'm grabbing everything. This is, I mean, it doesn't look like my list is actually reduced any, but I'm actually grabbing everything between the year and the day. And so what is that year and the day information here? The year starts from the first column, and the day goes over here. So what this should be doing here is saying, okay, here's the year and the day, but because we have this minus sign in front of it, that means don't take the year and day. That means take everything other than the year and the day. So if I change this to year to day, of course you can't see. Goodness gracious. Let me close some of these things down, everybody, just so I'm beginning to run out of space on my screen here, so I can't see everything. But if I go ahead and run this code here, year day, that code, then you'll see that I'm creating this year day, which is here, and that means that I just get year, month, and day. And you're probably thinking, well, how do I have just the year, the month, and the day? And that is because the year is the first column, the month is the second column, and the day is the third column. I could change this around just a little bit if you want. And so rather than going after the day, I'll go after the arrival time. And if I do that, I'll just run this again and click on this over here. You'll see now that I get the year, month, day, departure time, schedule time, departure delay, and the arrival time. Everything is mixed together. And that's, if I go back to the real flight data, you'll see that there's a bunch of other information here too. But what I'm doing is I'm actually going through and just grabbing specific columns from one column to another. Now, if I put this negative sign, if I put this negative sign in right here, sorry, but this negative sign right here means find out what this group is from year to arrival time, and then to leave it out and select everything else. And so it's like I guess the inverse selection of year to arrival time. And so if I run this, you're not going to see it. Well, I guess you can see it here. Okay, yeah, you can. If I run that, then I get scheduled arrival time, arrival delay, carrier, flight, tail number, origin, and destination, as well as some other things. And that is information that was everything that, there we go. It's everything outside of this selection. So going back to my slides, I think that if you just memorize that this select is actually able to go through and grab specific columns, just like this graphic shows us here. Here we have selecting data, and then it's saying go through columns A through F. That means just grab these columns A through F. And I think that the first column isn't necessarily selected, the last column is though, so the first one isn't included. Right, and the last one I wanted to talk about here is this mutate command, which again seems really creepy as a function, but but Halloween is coming, so it's appropriate. And why not? It's appropriate. But what we have now is we have a command to be able to grow a new column, actually to create a new column of data that we have. So let me go back and I'll just copy this first before I go on. Copy that. But let me go back and talk about how some of these columns that we have here are so-called redundant. Remember, going back to our column here, for instance, if I go to flights, you'll see that, where was that? It's between the departure time and the scheduled departure time, we have this number here called delay, departure delay, and we also have arrival delay. Now that number is the departure delay is the difference between the departure time and the scheduled departure time. At least it should be. I'm not sure why this is. No, sorry, it's the. Is my data gone corrupted here? Departure time, scheduled departure time. Okay, well, tell you what, I'm going to close this and load this again. So I'm thinking that something has happened. Okay, so if I do a view with a couple of V, flights, I think when everything is ordered, things kind of went out of the way. Here we go. Here we are. This seems to work now. The departure time and the scheduled departure time. I think I corrupted my data doing something there. I don't think that was a fault in our code, but I think that may be because of all the stuff I'm using on my screen. But the departure delay here is 2, and that's the difference between the departure time and the scheduled departure time. Now moving over here, you'll find that the arrival delay, like number 11, on column 1, or sorry, on row 1. 11 should be the difference between the arrival time and the scheduled arrival time. And so what I'm saying is that there's a column that exists which is actually made from a calculation of other columns. And so if we were to go back to our slides, we could use this command here called mutate, and that would then create a new column which would be based upon the calculations of data that's already existent somewhere, whether that's in your data or that's somewhere else. But I can actually create a column now, a new column in my data set, which I'll call in this case XY, just because I have no other ideas of what to call these things. It's getting late in the class, and so I'm running out of ideas. But you have this, you have now the ability to create another column of data. So I'm going to go ahead and try this. I'm going to I'll run this code. I'll just dump everything out. And I'm going to run this thing here. And so this mutate command is this. That's the actual function. Again, I have to tell it what is the name of the data set that I'm working with. So I'm saying, okay, here's the data set. Now, I'm not going to call this X, but I'll call this new day. Maybe that's more informative here. New day, let's say copy here. I'll call this new month copy. Just something to help me remember what this thing is. Now, when I run this, nothing much changes except for I have a new variable that shows up. Click on that variable, and you'll see that, okay, the data seems to be the same. But if you go all the way to the very, very end, aha, you have now a new column, 2 new columns. One is the day, new day copy, and the other one is new month copy. So what is that? Well, these are copies of day and month. And in fact, I could probably look at some of these and get an idea about. I could actually pick up maybe some of these and just look at these columns themselves. Let's see. I can select. Oops. Maybe I'll copy this out down here. Let's think. How do I do that here? X, Y, table, or something. I don't know. I'm stupid. I'll just say that's going to be here. Flights. I don't want to choose flights anymore. I'm going to be using my XY set that I've just created. And now what I want to see is I want to see, for instance, my day, and then I want to have new day copy, and I want to see, for instance, let's see, I'll call this month, and I want to see my new, oops, lowercase here, new month copy. Hopefully that'll do it. Okay, so I have this XY data, and so if I click on this XY data, you'll see now that I've actually used the commands that we've just gone through before to pull out this information. So if you can't really see much here, but if I move down to the bottom here, you'll see that new month copy, the month and new month copy are identical copies of each other. The new month copy is a clone of month, and the new day copy is a clone of day. And so how did that data work, or how did that code work? Well, it happened right here, where my code said, okay, look at the day and see what value is there, and whatever value you see there, copy that into this new column that we're creating called the new day copy. Then, at the same time, look at the month column here for each row, going down the rows here. And then whatever you find in the month, copy that value into this new column that we're creating called new month copy, and that will show you that will have the same number. Now, one thing I would like to say though is that one thing that I find difficult for myself, and I think that many of my students also find difficult about R, is that this is not traditional programming. And what I mean by that is when you're looking at the flights data, which is right here, let's go over here. When you're looking at your flights data, if you were to use, say, Java or Python or Golang or something else to run this analysis, or to actually create a new column, which is in function of another column, it sounds like a nested for loop, a for loop, or a while loop. While this is true, keep going and going round and round and round in circles until you have gone through all the rows and made copies of data in that row's tuple. So that's a loop. But when you look at the code in R, you'll see that really it's a one-liner here, and the code is written such that you're not looking at the data as a huge data set, but rather the data appears to be a specific variable. And I find that this was actually very difficult to swallow when I first saw this. Here I am using this select statement here where I'm going after this data set XY. Well, the XY data set is already this giant table. And now I'm saying that there's day that I'm pulling out, that's a column. New day copy, that's another column. And so I'm treating my data as columns of information. It's not just one number in a variable, but it's actually it's like each is an array, I guess. And so if you think in terms of your code is actually working with arrays, not specific individual variables, then it might be easier to swallow. But here, for instance, when I'm creating this day here, or this new day copy here in day, new day copy is what's happening is this is another column that I'm creating. But the code makes it look like it's just one piece of information in the column. But what's happening is in the code, it's actually taking this information and it's running the for loop and everything for you so that it's going through each of the rows. But you never actually see that for loop happening. And if you're used to like programming in Python or Java or JavaScript or any of those, or Golang or any of those languages where you have to have like for loops to work with arrays, it just seems odd. And so I don't know if you're feeling it, but when I see this kind of code coming together here, where it's just like one line, I think, well, wait, shouldn't there be a for loop to make this thing happen? Well, chances are, you don't need to run for loops. In this case, it's relatively easy to be given the code and then to run it. But when you start at this stage here, where I have this giant data set, and I need to pull out a column, and I need to run something else, and I need to create a new column, and I need to do this and do that, and the next thing, in my mind, I'm thinking there needs to be a for loop somewhere to make this happen. But actually, think again, because chances are there's an easy command that's just like this, which will handle this for you, and that means you do not have to write a for loop, which makes everything so much easier. We're not moving as quickly as I wanted to go here, but I'm hoping that maybe you have you're getting a better idea about how things are. Maybe on Thursday we'll finish up everything here, and then we'll move on to the actual slides that we have. The next thing I wanted to talk about here is this summarize command here. This is last but not least. This is actually kind of an important command here. It works with something else called group by. And what group by does is it takes the information here, flights, year, month, and day, and it makes information, it orders that information into like year or like month or like day. And so I'll just run this first of all, and you can have a look at it and see what happens. But when you use summarize, though, it works with the groups and says, okay, you've just written some code here, which has created certain types of, of groups of information here. Your groups have been organized according to some criteria. So here, if I type in by day, you'll see that, for instance, I have flights, year, month, day, or actually month, year, month, day. I'm creating groups. I guess you can't really see it in this case here. But you're actually creating in the memory of the computer here groups such that the data now is recognized by the year that it comes from, the month that it comes from, and the day that it comes from. And so you're organizing data according to some kind of I guess you call it a rubric. Now going back to the slides here, let's go again. Let's get the other piece of information. So I have to summarize. Why do we care about organizing our data by groups? Because then we have this command here called summarize, which is going to go through and say, okay, I'm now going to look at the groups of data that you have given me, and in this case, I'm going to tell you the mean of each of those groups. And so in other words, I've organized my data by the year, the month, and the day, and so it's going to go through and it's going to say, okay, well, by year, the years, it'll give me the mean of the departure delay. And so let me just copy this here. I'll get back to the mean here. So the mean of the departure delay, going out to my flights, that's saying, in general, how late are my flights taking off? Like how much time is it that they take to actually leave? And so I've already, oops, I haven't actually put my data up here. I should have done that. Just a moment here. Let me put that up here just so I get it back if I want it. So I have this, and then I'm going to summarize things. And so summarizing says, okay, when you look at the data from the year 2013, by the way, all of this data is 2013, so here it doesn't really matter. But when I'm looking at the first month of the first day, the mean for all the flights that took off on that day, the delay was 11.5. So that means that in general, the flights during the first day of the first month were 11.5 minutes late. That's not great. On the second day of, I feel like there's some kind of Christmas song here. On the second day of January here, the mean was 13.9. Now, this could indicate, this rise in numbers here could indicate things. I don't know whether that means something. But then we get, after the third day, it's 11 minutes late in general. Then we have 8 minutes, then 5 minutes, then 7, then 5, then 2, then 2. It seems like as the time is moving on, the numbers gradually decrease. And so that's actually quite important here. You're looking at information not as a giant table of information anymore, but rather you're kind of breaking up the table into time zones, or not time zones, parcels of time orchestrated pieces, such that you can look at the delays for specific days, at a specific month. And this will go on, in fact, I'll show you something. This goes back to the question that we had earlier. How do I actually see all this information in some oops, I don't want to see that. How do I actually see this information in some usable form? Well, let's just go ahead and make a variable for it. I'll just call this, I can't do anything else. It's getting late. I'll just call it S. And I run this, and then you'll see over here, S, you have your delays. And so you can go through and say, well, on each of these days, you have all the flights that I'm looking at on this year, for that month, for that day. The delays were this. Look at this. I mean, what happened on the 30th of January? On the 29th, the delay was 2.49, actually 2.50. But then the day after that, it seems like this next number, 28 minutes delay in general. The mean, by the way, is the average. And so the average delay that people had to wait was half an hour for the flights to take off on the 30th on average, on the 30th of January 2013. So you wonder, like, for instance, what happened? It looks to me as if maybe there was some kind of an engine problem, or maybe the airports had some trouble, or maybe that was just weather in certain areas. Something happened to push up this delay. And so you have this problem. I'm looking through these numbers now, and I'd love to know why it is that. So look at this. So it goes from, there's this average. The mean was 8 on 18th of February, and then on the 19th it went up to 17. I mean, could that be human error? Could that be weather? Could that be? Yeah, it could be anything. We don't know, actually. And why I'm mentioning this is because we don't know why those delays, why the averages were moving around in those delays at all. We have no idea. And so as data scientists, we really have to go through and kind of uncover the truth